Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equations with reciprocal ratios. But before we do that, we need to know what kind of values that the reciprocal ratios, i.e. sec, cosec, and cot, can take. So let's look at the domain and range of the function y equals cosec of x. So remember that even though cosec looks more like cosine, cosec x is actually 1 on sine x. So let's look at values that x can't take. Well, we would have a problem if the denominator was 0 because you can't divide by 0. So when is sine x 0? Well, that occurs when x is equal to 0 or pi or 2 pi, 3 pi, and so on. So we can't have x being any integer multiple of pi. So we write the domain as a set, the set of x values such that x is not equal to k pi where k is an integer. So that just says x can take any value except 0, pi, 2 pi, 3 pi, 4 pi, negative 2 pi, and so on. So we write the domain in set notation. We can't really use interval notation because there are infinitely many values we'd have to exclude. So that is the domain. X can take any value except an integer multiple of pi. So what about the range? What values can cosec of x take? Well, remember, we have to have that sine x is between -1 and +1. So when you divide 1 by a number that is between this, you get a number that's either more than 1 or less than -1. So y can take any negative value up to and including -1, but it can't be between -1 and 1. It can also take any value more than or equal to 1. It can't be between -1 and 1, and that's because sine of x here only lives between -1 and 1. When you divide 1 by a fraction or decimal, not a whole, then you get a number more than 1. All right, let's now look at solving an equation. So let's solve the equation √3 cot x plus 1 is equal to 0. So we're going to solve this in the usual way. We're going to move everything to the right-hand side that's not cot x. So we're going to subtract 1 and then divide by √3. Now, we're probably a lot better at using sine, cos, or tan because we have more experience with this. So, since cot is 1 over tan theta, why don't we make this into a tan equation? So, for tan x, all we have to do is flip the fraction. So, it'd be √3 on -1 or -√3 on 1. So this is easy to solve. We know that tan x equals √3 when x is equal to 60 degrees. So tan x is -√3 at 120 degrees or 300 degrees. So they are the two solutions between 0 and 360 degrees, but remember, if you add 180 to an angle, the tan of that angle doesn't change. Tan has a period of 180 degrees. So what I can do is add integer multiples of 180. So again, I have to specify here that k is an integer. So 300 degrees is actually covered by this if k was 1. So this is the general solution, 120 degrees plus any integer multiple of 180. Of course, if I was asked to give the answer in radians, I would give 2 pi over 3 plus k pi, where k is an integer. So that is the general solution to this equation. It's easiest if we turn cot, sec, or cosec into sine, cos, or tan because we have more experience with them. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.